Okay, let's go ahead and graph one more. So say we want to graph the 3 cosecant 2x plus pi. So again, first thing I'm going to do is say that cosecant is the same thing as 1 over sine. So I'm going to first graph 3 sine of 2x plus pi. So when I do that, I'm going to want to know the amplitude. My amplitude is that thing in front of the sine, so it's going to be 3. This is just a sine. Again, I'm just graphing the sine real quick. And I'm probably going to want to rewrite it because I want to pull out whatever's in front of the x. So 2x plus, if I divide pi by 2, it's going to be pi over 2. So my period is going to be 2 pi. This period of sine is 2 pi. Sorry, 2 pi came out looking a little weird because I started writing sine. Divided by 2. So my period of this one is just going to be pi. And this one's going to have a shift. It's going to shift left, so negative pi over 2. Okay, so I got all that. I'm going to go ahead and graph my sine then. Standard sine graph starts off at 0, 0, goes to 2 pi, middle point is pi, and that's where it crosses for sine graph, crosses the x-axis again. So in between that, at pi over 2, is when it gets to its highest point. Usually it's 1. We're going to go ahead and just make that 3 since we already know the amplitude. And 3 pi over 2. So again, usually that's negative 1, but we're going to make it negative 3 since we know the amplitude. So a regular sine graph looks something like this. Of course, this is not a regular sine graph. This has stuff changing, so let's go ahead and change a bit. The period isn't 2 pi, it's pi, and to get that period, I divided everything by 2. So I'm going to divide everything by 2. If I divide everything by 2, it's going to change all my points a little bit. My 0 is still going to be at 0. But my pi over 2, if I divide pi over 2 by 2, it's going to be pi over 4. That's where it's going to get the highest, which was 3. Then pi would be pi over 2. That's where it's going to go to 0 again. 3 pi over 2 would be 3 pi over 4. So that's where it's going to get to the lowest, which was negative 3. And 2 pi over 2 is just pi. So it's going to end at pi. So it should be shrunk in a little bit. If you were doing it on a real graph, it would definitely look like it's shrunk in. Really, it should be, the entire graph is going to fit into this space. Okay, so now we got our new period. Now I need to shift it. So this thing shifts left pi over 2. So we're going to go ahead and shift this left pi over 2, and we're going to draw it right down here. So if we shift this left pi over 2, then instead of starting at 0, it's going to start at negative pi over 2. Because I'm just subtracting pi over 2 from each point. So pi over 2 minus pi over 2 would be 0, so that's where it hits the x-axis again. And pi minus pi over 2 would be pi over 2. Which is where it ends at the x-axis. Highest it gets to would be halfway in between this. Pi over 4 minus pi over 2 would be negative pi over 4. That's where it's going to get to 3. And the lowest would be at pi over 4. 3 pi over 4 minus pi over 2 will give us that. That's where it's going to get to the lowest. So now again though, we're not graphing a sine. Our original thing was to graph the cosecant of 2x plus pi, 3 cosecant 2x plus pi. So we graph the sine, the cosecant is just 1 over that. So wherever it crosses the x-axis, we're going to put in vertical asymptotes. And we're going to draw the graph coming down to it and the graph coming up to it. And so this graph right here, this part of the graph is actually my cosecant.